So, 5.5, logarithms. Let's start in with some exponential expressions here. If I ask you to solve 3 to the x equals 9, you have no difficulty. Visual inspection, you get an answer of 2. If I ask you to solve, for example, 4 to the x equals 64, visual inspection, you get an answer of 3. So these are easy. 2 to the x equals 16, visual inspection, answer 4. How about if I give you something though like 2 to the x equals 15.38? What can you say here? Well, I know 2 to the 4th is 16, so x is probably going to be less than 4. 2 cubed is 8. So somewhere between 3 and 4, x is going to be somewhere between 3 and 4. Where between 3 and 4? Well, we're not sure. So what we first want to do is to develop a notation that allows us to solve for x. Basically, I want to take this expression here, 2 to the x equals 15.38, and simply have a way, develop a definition to say x equals something. And the way we're going to do that is we're defining a notation. X, note we're solving for an exponent here. In our original expression, 2 to the x equals 15.38, x is an exponent. I'm solving for that exponent, and I'm going to write the exponent is logarithm, base of 2, and that should make sense. My base here is 2, and my answer, 15.38. So I read this expression exponentially as 2 to the x equals 15.38. 2 to the x equals 15.38. And this is a definition. So I've defined this notation. So that means this notation is equivalent to base of 2 raised to an exponent of x equals 15.38. In one sense, a logarithm is simply an exponent, and that's a good mantra to remember. A logarithm is an exponent. This whole expression here is a logarithm. It is an exponent if I think about where it comes from, and it comes from an exponential expression. A logarithm is an exponent. And practically, we want to have logarithms because we want to have a way to solve. If we have a variable and an exponent that we can't visually, quickly find an answer to, we want to have a way to, in writing, solve for that variable that appears as an exponent. So, in general then, what we have is if a to the m equals n, then log base a of n equals m. Those are equivalent expressions. For example, 10 cubed equals 1,000. If I were to write that x logarithmically, I would have log base 10 of 1,000 equals 3.